In this video, we are going to tackle about distance, displacement, speed, and velocity. Now first, what is distance? Distance refers to how far an object travels, and it does not depend on direction. Now, say for example here, we have an illustration below. The ant crawls from 0 centimeter towards 3 centimeter. So what distance did the ant travel? It would be 3 centimeter. Next, okay, suppose that the ant travels from 3 centimeters toward 0 centimeter. Since the distance does not depend on direction, the ant's distance is still 3 centimeters. So does his direction change the answer? No, because his starting point is from 3 centimeters and travels towards 0. So that's a total of 3 centimeters. Now let's have another example here. Now, problem 1. John walks 10 meters towards the cafeteria and went back to their house. What is John's total distance? Distance is equal to, since he walks from 10 centimeters towards the cafeteria, put 10 meters. Plus, since he went back to their house and John's starting point is from their house, so let's add another 10 meters. So what would be John's distance? How far did John walks? 10 meters plus 10 meters is equal to 20 meters. So John walks 20 meters in total. So another example here, problem number 2. Fiona went jogging with a distance of 5 kilometers and another 3 kilometers towards her friend's house. Fiona jogged with a distance of 5 kilometers and another 3 kilometers. Now what is Fiona's total distance? So 5 kilometers plus 3 kilometers is 8 kilometers. So Fiona jogged 8 kilometers in total. Then lastly, we have the last one for the distance. A man travels 25 kilometers from his workplace towards their house and another 5 kilometers to the park. What distance did the man travel? So let's calculate. First is he travels 25 kilometers from his workplace towards their house and another 5 kilometers. We're just going to add everything when we are going to talk about distance. So 25 kilometers plus 5 kilometers is equal to 30 kilometers. So the man traveled 30 kilometers in total. So that's the distance. Regardless the direction that an object will go, we need just to add everything. So this is the formula. Distance equals distance 1 plus distance 2 or distance 3 and so on. So we just need to remember this formula. Now what is displacement? Displacement refers to the difference between an object's final position and its starting point. So it does depend on direction. So this is the formula. Displacement equals final position minus initial position. In order to define displacement, we need direction. So these are some examples of directions. Positive and negative sign, heads north, south, east, west could be in a form of angle. Okay, let's have an example. Okay, we're gonna solve a problem that we used in the distance example but in displacement. So John walks 10 meters east to the cafeteria and went back to their house. What is John's total displacement? So in the illustration here, John walks 10 meters east, so the arrow is towards right, and went back to their house. So let's assume that this is the starting point. Okay, John went back to their house. He goes back to the starting point, which is 10 meters west because the arrow is towards west. So our formula for the distance is, let's have, okay, so our formula for the displacement is a small letter d is equal to displacement number 1 minus displacement 2. So let's just remember that the sign that we use depends on where is the direction going. Okay, since they are opposite towards each other, remember that when the distance that John walks is opposite the displacement there is we use minus sign because John went back to his original position. So this is our formula. So distance is equal to our first displacement is 10 meters east minus our displacement number 2 is 10 meters west. So what could be John's total displacement? 10 meters east minus 10 meters west is 0. So John's total displacement is 0. Now let's have another example. Problem number 2. Fiona went jogging 5 kilometers north and another 3 kilometers south towards her friend's house. Identify Fiona's displacement. Okay, let's draw an illustration here. So assume that this is 5 kilometers north and another 3 kilometers south. So as we see here, they're still opposite to each other since north and south is linear, right? So we're still gonna use negative sign. So displacement number 1 is 5 kilometers north minus 3 kilometers south. What is Fiona's total displacement? 5 kilometers north minus 3 kilometers south is equal to 2 kilometers. So what would be the direction? We will, in this situation, will follow the highest possible given numbers sign since the highest possible number given here is 5 kilometers the given, so we're gonna use north as our direction. So the answer is Fiona's displacement is 2 kilometers north. Now let's move on to the next problem. Okay, a man travels 25 kilometers south from his workplace towards their house and another 5 kilometers west to the park. What is the total displacement? So let's draw an illustration to better understand the situation or the problem. Suppose that this is 25 kilometers south and this is the man's starting point, okay? And another 5 kilometers west to the park. So he went west towards the park. So what is the total displacement? So we see here in the graph, it's diagonal. So what are we going to do if they have different direction or they are not in linear form? They doesn't have opposite direction because the opposite direction of south is north and the opposite direction of west is east, right? In this problem, we're gonna use the Pythagorean theorem. This is in order to identify its total displacement, this line. So we're gonna use Pythagorean theorem. So what is Pythagorean theorem's formula? C squared is equal to A squared plus B squared. So that is the formula for the Pythagorean theorem. So what are we going to identify here is this line, the red line. So let's try to answer. So we have 25 squared. 25 squared plus 5 squared. 25 squared is equal to 625 and 5 squared is equal to 25. Now we'll add 625 kilometers south plus 25 kilometers is equal to 650 kilometers southwest. Now this is the final answer? No, this is not the final answer. We're still going to get rid of the squared here. So what we're going to do is identify the square root. The square root of 650. Now c squared, square root for c squared is c is equal to, what is the square root of 650? It is 25.50 kilometers southwest. So that is the direction. So the man's total displacement is 25.50 kilometers southwest. Now let's move on to speed. Speed is the rate at which an object is moving. So this is the formula. Speed is equal to distance over time. So just like distance, speed does not depend on direction. So let's have an example. Now let's have problem number 1. A man runs 100 meters in 5 seconds. So this is the formula for the average speed equals distance over time. Now the distance here given is 100 meters, okay, divided by 5 seconds is equal to 20 meter per second. So the man's average speed is 20 meter per second. Have problem number 2. A car travels 40 kilometers in 20 minutes. What is the average speed? So let's have the same formula. So this is the formula. Now the distance is 40 kilometers divided by 20 minutes. 40 kilometers divided by 20 minutes is equal to 2 kilometer per minute. The car's average speed is 2 km per minute. Problem number 3. An athlete runs a distance of 60 meters in 10 seconds. So what is the average speed? Let's just remember the illustration here. When we are going to find the time, we just only need to divide the distance and its speed. When we are going to find the speed, we just need to divide distance over time. And when the distance is needed, we need only to solve the speed and time through multiplying both. So in the problem here, the given is distance and seconds. So what we're going to identify is the average speed. So this is the formula. So the distance is 60 meters and divided with 10 seconds divided by 10 seconds. 60 divided by 10 is equal to 6 meter per second. So the athlete's average speed is 60 meter per second. Now let's move on to the velocity. What is velocity? It refers to the speed with direction. So this is the formula. Velocity is equal to displacement over time. Since it is with direction, we are using displacement. It has magnitude and direction. So magnitude means it is a measure that has a value. So what we are going to remember is velocity is equal to the displacement over time. So it has direction and magnitude. So let's have an example. Problem number 1. An astronaut takes 40 minutes to drive 20 miles north and then 20 miles south. What is the average velocity? To clearly understand the problem, let's have an illustration. So the astronaut takes 40 minutes to drive 20 miles north. Suppose this is 20 miles north, heading north, and then 20 miles south. So he went back south 20 miles. Remember that this is the starting point of the astronaut, and then he just went back. So let's try to solve. So average velocity is equal to displacement over time. What are the displacements? So the displacement here is 20 miles north and then 20 miles south. Since the astronaut's direction is opposite to each other, we need to find the difference. So 20 miles north and 20 miles towards south. The time is 40 minutes. So 20 miles north minus 20 is 0 divided by 40 minutes. The answer in this problem is 0. It is because from the starting point, the astronaut just went back. So we cannot identify the direction because he just went back to its starting point, even if there is time given. So the average velocity of the astronaut is 0. Let's have problem number 2. If a sprinter runs 100 meters in 10 seconds, what is his average velocity? So our formula is velocity is equal to displacement over time. What is the displacement? 100 meters divided by time. It's 10 seconds. 100 meters divided by 10 seconds is equal to 10 meter per second. So the sprinter's average velocity is 10 meter per second. Now let's have problem number 3. An airplane heads 100 kilometers eastward when a huge wind approached heading 5 kilometers north. What is the resultant velocity of the airplane? Let's draw a graph. There, 5 kilometers north. Okay, here. What we are going to find is here. Since the given can be formed in a diagonal shape, we can be able to use the Pythagorean theorem. So again, this is the formula for the Pythagorean theorem. Now let's try to solve the resultant velocity of the problem. So a squared will be the 100 kilometers squared plus the 5 kilometers squared. So 100 squared is equal to 10,000 kilometers. Plus 5 squared is equal to 25 kilometers north. 10,000 plus 25 is equal to 10,025 kilometers northeast. We still need to find the square root of 10,025 kilometers. C squared. So we need to identify the square root. C is equal to square root for 10,025 kilometers is 100.123 kilometers northeast. So the final answer, so the resultant velocity of the airplane is 100.123 kilometers northeast. And that ends our discussion. I hope that you already know how to identify the distance, displacement, speed, and velocity. Thank you so much. This is Hanelet. Adios.